All right, let's talk about something that's at the heart of good software development. We're going to dive into Robert C. Martin's legendary book, Clean Code. This isn't just about coding, it's about a philosophy, a way of thinking that can take you from just being a programmer to being a real software craftsman. So let's start with a really powerful question from the book. Imagine two rooms. One is spotless, organized, everything's in its place, and it's just a joy to be in. The other? It's a total mess, chaotic, you can't find anything. Martin asks us to think, which of these rooms is our code? And, maybe more importantly, why are we in that room to begin with? This one question really sets the stage for everything we're about to discuss. And that question leads us perfectly into our first section, the very real cost of a mess. Because, this isn't just about making things look pretty. Messy code has a real, tangible, and honestly, a very high price. Here's the bottom line. The fundamental problem with messy code, it just makes you slow. We've all been there, right? A project kicks off, everyone's flying, things are getting done, but then, bit by bit, progress just grinds to a halt. And 9 times out of 10, the villain of the story is the ever-growing pile of bad code. The book calls this the death spiral. It's insidious. Every time you need to add a new feature or fix a bug, you have to wade through this tangled knot of code. You make one little change over here, and suddenly something completely unrelated over there breaks. It's maddening. And eventually, you spend all your time fighting the mess instead of building cool new things. The team gets bogged down, and productivity just flatlines. Okay, so if messy code is so obviously destructive, why do we write it? Even really good developers do it. This brings us to what the book calls the programmer's conundrum, and it's a conflict every single one of us has to face. At the heart of it is this huge lie we tell ourselves, that we can go faster by making a mess. We think we're trading quality for speed, but the book just slams the door on that idea. It says making a mess slows you down immediately. The only way to go fast and to stay fast is to keep the code clean from the get-go. And that other thing we say? Oh, I'll go back and clean it up later. Well, there's a name for that. It's called LeBlanc's law, and it's brutally honest. Later equals never. So if messy code is the disease, clean code has got to be the cure. But what does clean even mean when we're talking about code? It can feel a little abstract, right? Well, the book pulls in some of the biggest names in the industry to help define it. Bjarne Stroustrup, the guy who literally invented C++, talks about elegance and focus. I love his point that bad code is like a temptation. It sends a signal to everyone else that quality isn't a priority here, and that just invites more and more mess. Then Michael Feathers adds this crucial layer, maintainability. Clean code is written for other people. It needs to be so clear that the next developer who comes along can actually understand it and build on it, without being terrified of breaking everything. And Grady Booch gives us this beautiful analogy. He says clean code reads like well-written prose. Think about that. When you're reading a great book, the words themselves kind of disappear, and you just see the story. That's what clean code should do. It should be so clear that the programmer's intention just shines right through. And all of this is perfectly captured by the broken window theory. You've probably heard of it. The idea is that a single broken window on a building sends a message nobody cares. And pretty soon, more windows get broken, and the whole place starts to decay. It's the exact same thing in a code base. One little piece of sloppy code is that first broken window. It tells the team that quality isn't valued, and before you know it, the rot starts to spread everywhere. So, how do we fight back? How do we actually put this philosophy into practice? The book is packed with principles, but let's just focus on 3 really simple but incredibly powerful rules for writing cleaner code. Rule number 1 is, you could argue, the most important of all. A variable named D or a list named the list tells you absolutely nothing. Naming isn't some trivial thing you do at the end. It is a critical act of communication. The name of a variable, a function, a class, it should tell you its story. Why does it exist? What does it do? How is it used? Just look at this transformation. It's night and day, right? D becomes elapsed time in days. This cryptic line of code becomes game board 0 equals status flagged. It's self-documenting. With one simple change, you get rid of the need for a bunch of comments, and the code's purpose becomes instantly obvious. Okay, rule number 2 is all about functions. They should be small, and once you think they're small, you should probably try to make them even smaller. We're not talking 20 or 30 lines here. The book pushes for functions that are just 2, 3, maybe 4 lines long. And, this is critical, each one has to have a single, focused responsibility. It does one thing, and it does that one thing well. Now, the key here is that this is a process. You don't just sit down and write perfect, tiny functions from scratch. No way. You start by writing code that works, even if it's a bit messy. Then you refactor, you attack it, you mercilessly break it down into smaller and smaller pieces, and all the while your tests are your safety net, making sure you haven't broken anything. The end result is this beautiful collection of tiny, focused functions that are a breeze to understand, test, and reuse. And rule number 3 might just be my favorite, the Boy Scout rule. It's such a simple, powerful ethos. Leave the campground cleaner than you found it. Applied to code, it means every time you check in a file, you make one tiny improvement. Rename a variable, split a function, anything. If every developer on the team does this, the code base doesn't decay. It actually gets better over time. So when you put it all together, the naming, the small functions, the Boy Scout rule, you realize these aren't just items on a checklist. They're all pointing toward a fundamental shift in perspective, a different way of thinking about what it even means to be a programmer. And this leads to what is, for me, the most mind-blowing statistic in the whole book. The ratio of time we spend reading code versus writing it is more than 10 to 1. Let that sink in. 10 to 1. That fact completely reframes our entire job. We are not just mechanics telling a computer what to do. We are authors, and we are writing for a human audience, our teammates, and of course, our future selves. Our number one job is communication.
And that's really what this all boils down to. Getting something to work is just the entry ticket. That's the bare minimum. A true professional takes responsibility for the quality of their work.